What's up, everybody? Welcome. This is page 395, and we are talking about tangent segments, and tangent segments are congruent. We have the first example that we're going to work on. So I did make a card that'll remind us that if you have tangent segments of a circle, then the tangent segments will be congruent if they're drawn from the same point. So for example, in number 4, PK and SK are the same, because they are tangent segments drawn from the same spot. So now we can say circle W, angle PKS, so this angle, has a measure that is 46 degrees. So drop in a 46. Did you notice that's not a right triangle, that's an isosceles triangle? This whole thing, as a triangle, has two sides that are the same. So therefore it has base angles that are the same. And in this case, the base angles P and S are congruent. So if we want to figure out the measure of KPS, KPS is this angle, it'll be half of whatever's left when you subtract 180, because we're using layers of things in this problem. The measure of the degrees in a triangle is 180. One of those angles is 46 degrees. The other two angles, I'll label with X and with X, we don't know. But we can use algebra to solve and find out. Okay, some subtraction. So what is 180 minus 46? I want to subtract by 46, by the way, because I want no numbers on one side of the equation, only letters. And then I'm going to subtract 46 over here. So 180 minus 46 is 134, right? Because I can add the 4 and the 6 and add the 3 and the 4. It makes, okay, so 134. But it equals 2x, right? It's a degrees. It equals 2x. X plus x is 2x. So I'm going to combine like terms. I'm combining the x's to make a 2. And now I'm going to do my last step. I'm going to divide by 2. Okay, so I know that 140 divided by 2 is 70. And 120 divided by 2 is 60. So we're somewhere between 60 and 70 as an answer. I'm going to guess 67. In fact, yes, that is what I'm going to say for my answer. I'm going to say 67 is my answer, because when I double it, I do get 134. Doubling the 7 makes 14. So there you have it. The measure of angle KPS is 67 degrees. Why? Because of tangent segment theorem. Let's keep going. Number 5, in the figure, so we have this shape, there's a tangent line, and we have that PS is tangent to circle M. So here's my tangent segment. We have a 90-degree angle. When you connect the tangent line to the radius of the circle, they form a 90-degree angle. So now we know that this is 90, and we know that angle SMO, so angle SMO is this outside angle of 119 degrees. What else do we know from a point of tangency? Okay, I'm going to answer the question. Calculate angle MPS. And angle MPS is this exterior angle here. Now, some things that we can do with exterior angles, you would take this value and subtract it by this value. That's the intercepted arcs, and then divide by 2. Or we could take these two angles, because this makes a triangle, this exterior angle of 119 is equal to these two angles added together. So one of them is the exterior angle, and the other is the 90-degree angle there. So I could take away 90, and that would tell me the measure of angle MPS. 119 minus 90. I want to do it the other way, though. I want to do it the exterior angle way. So the arc that is subtracted there would be 119. The measure of angle MPS would be 119 minus. Now I need to know what this arc right here is. And since all of this is 180 and this is 119, maybe I just focus on how this is 180 minus 119. Okay, I need a little bit of help here. What is 180? I think it's like 61, 62. 180 minus 119. Yeah, 61. This is supposed to be a 61-degree intercepted arc on the other side. Okay, So I can put 61 there. Now, if I do 119 minus 61 and then divide by 2. So let's see here. I want to go with this one. 119 minus 61 gives me 58. And then half of 58 will be my answer. 29. Oh, this was also 29. Hey, both methods. Pick your favorite. Use it. They both wind up giving you the same answer of 29 degrees, as in angle P is a 29-degree angle. We have one more. We have the last question on this page. And if I check forward, ooh, it's the last one for this activity. We'll do the talk, and finish out the lesson. Consider the figure. Circle B and circle O are tangent circles. They touch they touch right here. This is a point of tangency between the two circles. Interesting. The length of the radius BR is 4. You know what that means? That is also a 4. The length of radius OT is 7, which means this is also a 7, because all radii of that same circle are going to be equal. So 7 there, but 7 here. 4 here, and 4 here. So then segment RT is called a common tangent. Calculate the length of segment RT. As a common tangent, it is tangent to both of them. So it's shared by both. What is the shortcut way of doing this? I'm going to go the way that my brain thinks is the right way, and it's probably the long way through, but we'll work through it. Here's what I think we should do. I think we should draw a triangle just by chopping this trapezoid into a rectangle and a right triangle combination. If this is 4, then 4 will slide all the way over to this side so that this line is broken up into a segment that is 4 and the rest of 7. 3. 4 plus 3 makes 7. Now we have a right triangle. We want to find the length of segment RT. So if I slide this down to here, this is the same length as RT, because I made that rectangle, and opposite sides of rectangles are equal. And again, this is the path that I'm thinking right now. I might look at my answer notes from the book and be like, oh, I could have just done it with like a 5 instead of a 3. Point is, I'm dividing the trapezoid into two shapes, a rectangle shape and a triangle shape. And now this triangle, the unknown side right here that I'm calling X, is the unknown side of a right triangle. So I have a hypotenuse of 11, a little quick redraw, and a leg of 3, and an unknown side of x. So to solve for it, I'm going to solve the Pythagorean theorem. X squared plus 3 squared equals 11 squared. Okay, quickly running out of time. X squared plus 9 equals 121. Subtract 9 from both sides. X squared equals 112. Take the square root, take the square root. I'm going to say that RT equals the square root of 112. No, I don't need to solve for it. Although if I did, I could say, hey Siri, what's the square root of 112? And then Siri might actually answer my question.
The square root of 112 is approximately 10.583.
Thank you, Siri. Okay. Thank you for watching this video and for checking in. See you in the next video. Talk the talk. We'll finish the lesson. Like, comment, and subscribe. Bye.